On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to talk about the end behavior of polynomials, not trigonometric functions, not logarithms, not rational functions, just polynomials here. And what we want to focus on in any given polynomial, we're going to look at these two here. We're going to go over into Desmos and look at even more. I'm just going to change a few things, and we're going to see how this end behavior does change based on degree and leading coefficient. To refresh your memory on degree is going to be the highest power that you see in your polynomial. For example, f of x, we have a degree of 2. That's the only power we see. G of x, our degree is 3 because that's the highest power that we see there. So notice we can have even degrees and odd degrees. We do not focus on rational exponents here because we're talking about polynomials. Then we also have to look at the leading coefficient. The leading coefficient is going to be the number in front of that variable with the biggest exponent. For example here, 3 is the leading coefficient. It's positive. So the way we use this table here is we said, okay, we got an even degree, we got a positive leading coefficient, so we're talking about this little spot right here, even degree, positive leading coefficient. What this tells me is, I don't know what goes on in the middle, but I can guarantee the y value, the limit, as x approaches infinity or as x approaches negative infinity. Now, x approaching infinity goes this way, x approaching negative infinity goes that way. The limit is going to be positive infinity regardless. So looking at these two examples here, without even looking at a graph, we have limit x approaches infinity of f of x, and that's the one we were just talking about. Even degree, positive leading coefficient. As x gets big, the limit's going to get big. The y value is going to shoot off to positive infinity. Sure, technically the limit doesn't exist, but it's still good to talk about what's the y value doing. The y value is shooting off to positive infinity. Same thing over here on this one as well. The limit as x approaches negative infinity, well, that's when we go to the left, the y value is going to shoot up as well. And again, we are going to look at this and many more examples over in Desmos. But now let's look at this second one, the g of x. G of x has a degree of 3, so that is an odd degree. And notice its leading coefficient is a negative number. It's okay if it's a fraction here, we just don't want fractions in our exponents when we deal with polynomials. So we have an odd degree, negative leading coefficient, so we have this behavior here going on. We don't know what goes on in the middle, don't really care about this for these particular examples, but we can guarantee as x goes to the right, as x goes to positive infinity, the y value goes down, 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 down. So as x goes to the right, as x gets really big, the y value gets really small. That's what that arrow means there. The y value is going to go down to negative infinity. Now as x goes to the left, as x goes to negative infinity, the y value gets really big. So this limit over here is going to be positive infinity. Let's look at these two examples, and then I'm going to manipulate these to get you to understand what these things tell us, just in case you're a bit confused right now. So here's our f of x, 3x squared, and notice as x gets really big to the right or as x gets really small to the left, the y value is taken off to positive infinity in both directions. That's exactly what we said in the first two problems we addressed. Notice g of x now. This is the one with the odd degree, the negative leading coefficient here. As x gets really big, as x goes to the right, the y value is going down, as you can see there. As x gets really small, as x goes to negative infinity, the y value gets really big. As you can see, the graph continues to go up. Guaranteed. Now, let's come in here and change a few things. I'm going to come to f of x. I'm going to add plus 5x to the fourth. Our degree is now 4 because that's the highest exponent. That's still an even degree. Our leading coefficient here is still positive, so we have that same end behavior as we had originally with f of x. As x gets big or as x gets small, the y value shoots off to positive infinity. If I change this positive 5 to a negative 5, notice our end behaviors now go down in both directions. As x gets really big, as x goes to positive infinity, that limit, that y value is approaching negative infinity. The same thing applies as x gets really small, as x goes to negative infinity, our limit is going to be negative infinity. Let's come over here to this one, g of x, and let's change its leading coefficient to a positive. So I'm going to delete that negative there, and now our end behavior has switched on us. Take note of these things that you see in orange. This is exactly what just happened. We had this end behavior originally with a negative leading coefficient on an odd degree. When I took that negative away, we kind of have this behavior going on now. Notice that end behavior. As x gets really small, as x goes to negative infinity, the y value also goes to negative infinity. And as x gets really big, as x approaches positive infinity, our y value gets really big. Our limit is positive infinity. And you can come in here and you can manipulate this. If I change that 3 to a 7, we're still going to have that same end behavior there because it's still an odd degree. We have a positive leading coefficient. If I come in here and change this 1/2 to a 4, whatever, we're still going to have the same end behavior, odd degree, positive leading coefficient. If I make this 4 a negative, that's when it switches on us, as you can see here. And I encourage you to go over to Desmos and just type in some polynomials. Don't mess with any of these down here. That's for another video or one I've already done in the past. But these up here are polynomials. Just go to Desmos, type a few things in, and notice that end behavior. If I come up here to f of x and I change this to the 26th power, you are going to see something change here. The reason why, originally, this was a 2. So 4 was our degree. But now if I make this 26, the 26 becomes our degree. Its leading coefficient is positive. That's why we're shooting up as x gets big or as x gets small. Our y value gets big in both directions. And there you have it. 2 examples plus several more that we did over in Desmos, just looking and seeing how that end behavior changes based on our degree and the sign of our leading coefficient. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.